everyone, welcome to IIT-JAM in Chemistry tutorial number 44, and this is part 2 of lecture number 3 of the physical chemistry chapter solid state. Here we are going to discuss numerical problems on X-ray diffraction and Bragg's law. Since previously we have discussed 5 numerical problems, so as a continuation this should be question number 6. So this question came in IIT-JAM 2024, and this question is wavelength of X-rays used in diffraction experiment is 1.54 angstrom. X-rays are diffracted from a set of planes with an interplanar spacing of 1.54 angstrom. Then the angle theta, that is the glancing angle in degrees, corresponding to the first order Bragg diffraction should be what? You are given 4 options here: 30 degree, 15 degree, 45 degree and 90 degree. So let's find out the answer here. So as we know the Bragg equation, which is n lambda equals to 2d sine theta. So let's compute the data first. Since this is the first order Bragg diffraction, so the value of n should be 1, and as the values of lambda and d given, both are 1.54 angstrom. Therefore, just rearrange this equation: sine theta, which is n lambda by twice d, and let's put the value in place of n. We put 1 here. In place of lambda we put 1.54. This is 2 as usual. And this is d. In place of d we put 1.54. So this is nothing but 0.5 or half. Since sine theta is half, then theta must be 30 degree. Therefore the correct option must be option A. Next question, question number 7. This question came in IIT-JAM 2022. So you have to find out the d spacing for the first order. That means the interplanar distance for the first order Bragg diffraction for iron. Iron actually has the space lattice FCC, face centered cubic, and the glancing angle, the 2 theta value. If theta is the glancing angle, then the 2 theta value is given 20.2 degree. You are given the value sine 10.1 degree, which is 0.1754. So you have to find out the interplanar distance. So let's find out the answer here. We know Bragg equation: n lambda equals to 2 sine theta, and let's compute the data. N equals to 1, lambda given 1.54 angstrom, 2 theta is 20.2 degree, that is theta equals to 10.1 degree. Therefore, the value of the interplanar distance d must be n lambda by 2 sine theta. So in place of n we are putting here 1, in place of lambda we are putting 1.54 angstrom, and this is 2 as usual. Sine theta, that is sine 10.1 degree. So let's put the value of sine 10.1 degree, which is 0.1754, and the final result is 4.39 angstrom. Therefore the correct numerical entry should be 4.39. Next question. Question number 8. This question came in IIT-JAM 2021. Now the monochromatic X-rays having energy, here the lambda is not given. Okay, only the energy of that X-ray beam is given here, which is 2.8 into 10 to the power minus 15 joule, and is diffracted in first order pattern. And from which plane? The 200 plane. Which crystal system? The cubic crystal system, at a glancing angle what? 8.5 degree. So you have to find out the length of the unit cell, that is the edge length. So 4 options are given here, and you are given the value of the Planck's constant h, the velocity of light, and sine 8.5 degree. These 3 values you are given. So let's find out the answer. First of all, we have to use the Planck's equation, where energy equals to E equals to h nu, where E is energy, h is Planck's constant, and nu is frequency of light. Now nu can be replaced by c by lambda, where c is velocity of light and lambda is the wavelength of that light. Here light means X-ray. So from here you can find out the value of lambda. So lambda must be equal to hc by E. Now just put the values in place of h, the Planck's constant in SI unit, the value of velocity of light in the SI unit, as well as the energy also in the SI unit. Therefore the value of lambda must come in the SI unit, that is in meter. And the result of the calculation is 7.01 into 10 to the power minus 11, and the unit must be meter. So we get the value of the wavelength of X-ray. Now let's take the help of the Bragg equation, which is n lambda equals to 2d sine theta. From here you can find the value of the interplanar distance d. So the value of interplanar distance d is n lambda by 2 sine theta. The value of n is 1, you are putting 1 here. The value of lambda, as we have found out the value of lambda, this is 7.01 into 10 to the power minus 11, and 2 as usual, and sine theta, that is sine 8.5 degree, which is nothing but 0.1478. So you put the value here, and the result of this calculation is 2.37 into 10 to the power minus 10 meter, and since we know that 10 to the power minus 10 meter is 1 angstrom, therefore this is nothing but 2.37 angstrom. Now this is the value of D. So what should be the value of A? We know that D equals to A divided by root over h square plus L square plus h square plus k square plus L squared. Therefore A, that is edge length, is equal to interplanar distance D into root over h square plus k square plus L square. You are given the value of h, k and L. H is equal to 2, k is equal to 0 and L is equal to 0. So this way we get the value of A with the help of D and h, k, L. So the result is 4.74, which is almost equal to 4.8. Therefore the correct option must be option C. Let's move on to the next question, question number 9. This question came in IIT-JAM in 2019. So this question asks you that a first order reflection of X-ray from 220 plane of copper crystal is observed at a glancing angle of 22 degree. The wavelength of X-ray used is what in picometer unit? You have to round it off to 1 decimal place, and also you are given the copper, given the data that copper has FCC crystal lattice, and the edge length is 361 picometer, and the value of sine 22 degree is 0.3746. So let's find out the answer here. First of all, let's calculate the value of D, which is A over root over h square plus k square plus L squared. So we know the plane is 220 plane, therefore put the value 2 in place of h, 2 in place of k and 0 in place of L, and the result would come in picometer unit, because you are putting the value of A in picometer unit, which is 361 picometer. Therefore the value of D is 361 divided by 2 root 2 picometer. Now with the help of Bragg equation you can find the value of lambda. Okay, so this lambda is 2d sine theta by n. So 2 as usual, d 361, and then sine theta value is given here 0.3746. So put the value 0.3746 and divided by n into 2 root 2. That is, this 2 root 2 actually 361 by 2 root 2. So here in the numerator 361 and in the denominator 2 root 2. That is why this 2 root 2. So the value of D is not 361. The value of D is 361 by 2 root 2. I haven't merged this equation. Okay, just put it here, and final calculation will be done from here. So the final calculation from here, we get the value of lambda, which is 95.6 picometer. Therefore 95.6 should be the correct entry. Now let's move on to the next question, which is question number 10. So here in this question came in IIT-JAM 2016. Okay, in a diffraction experiment with X-rays of wavelength, that means the wavelength of the value of X-ray, that is lambda, is 1.5 angstrom. Okay, a diffraction line corresponds to 2 theta. If theta is glancing angle, then 2 theta value is given at 20.8 degree, which is observed. So the interplanar distance in angstrom is, so you have to find out the value of interplanar distance D in angstrom unit. So let's find out the answer here. So if 2 theta is 20.8 degree, then theta is 20.8 divided by 2, that is 10.4 degree. Therefore the value of D must be n lambda by 2 sine theta. So put the value of n, which is 1, the value of lambda 1.54, and 2 as usual. Sine theta means sine 10.4 degree, and the value of sine 10.4 degree is 0.18052. Since this is 2016 question, so that time calculator or log table may be allowed in the example. That is why this data is not provided. Okay, so you can take the help of calculator or log table and you can find the value of this sine 10.4 degree. Okay, and this way the final calculation gives the result 4.26 angstrom. So you have to just make an entry of 4.26 only. This is an NTA type of question. Next question, question number 11. This came in IIT-JAM 2015. At what angle or angles of incidence X-rays of wavelength 5.0 angstrom will produce diffracted beam from the 110 planes in a simple cubic lattice with edge length A equals to 10 angstrom. So let's find out the answer here. So the data A is 10 angstrom. Okay, Therefore, what should be the interplanar distance? The interplanar distance A divided by root over h squared plus k squared plus L squared. The value of h is 1, the value of k is 1, and the value of L is 0. Okay, so this is 1 squared, 0 squared. So this is nothing but A by root 2, and the value of A is 10 angstrom. Therefore this is 10 divided by root 2 angstrom, and the final calculation is 7.08 angstrom. Now sin theta. Sin theta from n lambda equal to 2d sin theta must be n lambda by twice d. So the value of n, as it is first order, if nothing is given, then you have to then consider it to be first order. Okay, here the order is not mentioned at all. Therefore you have to consider this to be first order. Okay, so you must keep in your mind that if order is not mentioned, then you must take the value of n equal to 1, because after the zero order, the most intense line, the next most intense line is the first order diffraction comes from the first order diffraction. And since from zero order diffraction you cannot find out anything, okay, you cannot sort out anything from zero order diffraction, so you have to take help of the first order diffraction, which is the most intense line produced from X-ray diffraction. Therefore, if nothing is mentioned here, you must take the value of n as 1 or unity. Now the value of lambda, as it is given, 5 angstrom. So this value 5 angstrom is put here. Then 2d, 2 into 7.08, we have just found it out. And the final value of sin theta is 0.356. Therefore, the glancing angle is sin inverse 0.356, which is 20.7 degrees. So option C is the correct answer. Next, question number 12. This came in IIT-JAM 2014. A first order reflection from 111 plane is observed for lithium halide with 2 theta equals to 24.6 degree and with lambda value 1.54 angstrom. Assuming lithium halide to be a cubic crystal system, that is CCP, okay, cubic crystal, that is simple cubic, and you have to calculate the length of the side of the unit cell in angstrom, that is the edge length A, you have to find out. So you are given the glancing angle, the 2 theta value. If glancing angle is theta, then the 2 theta value is 24.6 degree, that is theta is 24.6 divided by 2, that is 12.3 degree. Now the value of D, the value of D must be n lambda by 2 sin theta. The value of n is 1, lambda is 1.54. The 2 sin theta means 2 sin 12.3 degree, and it is nothing but 2 into sin 12.23 degree, that is 0.213, and the final result of this calculation is 3.61 angstrom. Therefore, the edge length A must be d into root over h squared plus k squared plus L squared, that is 1 squared, 1 squared, that is root 3. So 3.61 into root 3 angstrom, that is 6.25. So the correct entry here, it must be some correct entry, because this is also NTA type of question. No, because no options are given here, so you have to just type 6.25. okay, this is angstrom unit. Next, question number 13. This question came in IIT-JAM 2013. A hypothetical element which has atomic weight of 300 crystallizes in a simple cubic lattice, okay, SC. For this crystal, the first order and the HKL value is 100. X-ray diffraction with wavelength of 5 angstrom appears at an angle 30 degree, that is the glancing angle, theta is 30 degree. You have to find out the density of the crystal in gram per cc, and you are given here the Avogadro number 6.02 into 10 to the 23. Okay, this is also NTA type of question, so let's find out the answer. So interplanar distance D must be equal to, from the Bragg equation, n lambda by 2 sin theta. So the value of theta is 30 degree, so it is n lambda by 2 sin 30 degree. And now put the values. In place of n, you put 1 here. In place of lambda, you put 5 here. So the result must come in angstrom unit, because you are putting the value of lambda in angstrom unit. Now 2 sin theta means 2 into 0.5. We know the sin theta value, sin 30 value. Okay, it is memorized to all of us. Sin 30 is half or 0.5. So the result of this calculation is 5 angstrom. So the interplanar distance is 5 angstrom. Therefore, the edge length A must be d into root over h squared plus k squared plus L squared. Since this is 100 plane, so this is simply d into root over 1 squared plus 0 squared plus 0 squared. Again, this is 5 angstrom. Now density. Density rho must be mass by volume. We know that. Now, if you take the unit cell, then you have to take the volume of the unit cell also. So if you divide the mass of the unit cell by the volume of the unit cell, then this is also density of that metal. Okay. Now here this is since this is simple cubic, so a simple cubic lattice contains 1 atom per unit cell. We know that because phase FCC contains 4 atoms per unit cell, BCC contains 2 atoms per unit cell, base centered cubic lattice contains 2 atoms per unit cell, but here the simple cubic contains 1 atom per unit cell. Therefore 1 unit cell means mass of 1 unit cell means the mass of 1 atom. Okay. Therefore you have to put mass of 1 atom, and the volume of 1 unit cell is nothing but the cube of the edge length of the unit cell, and we know the edge length of the unit cell, which is 5 angstrom. So now from here you can calculate the density. But what is the mass of 1 atom? Mass of 1 atom means the atomic weight divided by Avogadro's number, because atomic weight, which is here 300 gram. Okay, 300 means 300 gram. This is the mass of Avogadro number of atoms, that is 6.02 into 10 to the 23 number of atoms. So what should be the mass of 1 atom? So you have to divide this weight by Avogadro number. Okay, so that is why we are doing so. And here in the CGS unit, since it is the value of the atomic weight is in the CGS unit 300 gram, so you have to convert this value of A in the CGS unit also. Since this is 5 angstrom, so you have to convert this into centimeter. Okay, then it will become gram per centimeter cube, that is gram per cc. So we know that 1 angstrom is 10 to the power minus 8 centimeter. Therefore 5 angstrom is 5 into 10 to the power minus 8 angstrom. Okay, 8 centimeter. Now the whole cube of this thing. So just put the value of the atomic weight is 300 gram, the Avogadro number, value of Avogadro number, which is gram per mole, per mole. The unit of Avogadro number is per mole, and the unit of atomic weight is gram per mole. Okay, so per mole cancelled. Now gram remains, and here centimeters whole cube, that is centimeter cube. So it becomes gram per cc. So the final result is 6.64 gram per cc. So the density of that metal must be 6.64 gram per cc. The correct entry should be 6.64. So that's all for this today's lecture. Thank you and have a nice day.